You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Fermyon is the first cloud-native WebAssembly FOSS that helps developers build better serverless apps faster. Fermyon is focused on empowering cloud developers to quickly realize the things they are thinking about creating and focus on the code that brings value instead of the obligatory foundation code. Hello, everyone, and welcome to another episode of The New Stack Makers. I'm your host, Heather Joslin, Features Editor at TNS, and today we're going to talk about something you've probably heard about but might be having some trouble wrapping your head around. That's WebAssembly, and specifically we're going to talk about where it fits in the ever-expanding cloud-native landscape. And we have a great guide today to help us explore this topic, Matt Butcher, co-founder and CEO of Fermyon Technologies. Hi, Matt.
Hi, great to be here today.
It's great to have you. And Matt and I have spoken before on Makers, so I think of him as today's returning champion.
Well, thanks. That's a good high bar to set there right out of the gate.
Right. So we'll try to live up to it today. So
Right.
Can you tell us a little bit, Matt, about what Fermyon Technologies does?
Yeah. So a couple of years ago, a group of us got really excited about the idea that there were two kinds of cloud computing that we saw already that were doing really good things, virtual machines and containers. But we saw this potential for a third kind of cloud computing, and started one that had nearly instant startup times and high security profile and all these kind of key features to making serverless computing move beyond where it was. We started Fermyon Technologies to kind of pursue that vision. And WebAssembly, which we'll talk about today, is kind of that key feature, that key technology that we think enables this kind of story.
Great. And also, I just want to thank Fermyon Technologies for sponsoring today's conversation. So let's get to it.
All right.
So let's start with something very basic for those listeners who might have heard of WebAssembly, but they're not quite sure what it is. Could you give us a quick elevator pitch definition of what WebAssembly is?
Yeah. I think the easiest way to talk about technologies like this is to talk about their purpose for being invented and then go from there to see how the potential has sort of unfolded. And WebAssembly was built really to solve a problem in the web browser world. And that was that, JavaScript is the primary language for web development. And for a long time, it was not possible to use other existing languages like Rust or C or Python or Ruby inside of the browser. And a consortium of engineers from Mozilla, from Microsoft, and the Chrome team at Google, and the Safari team at Apple, they all got together and said, we can build a sort of platform agnostic virtual machine, much like the Java JVM, that could run in the browser and could run all these different programming languages. So it got started kind of in there. And if you look at Figma and Adobe, those are big users of the technology in the browser space. But it turns out that particular profile of being able to compile different languages to the same binary format, that offers solutions in a lot of other areas. And so recently we've seen WebAssembly, this core technology where you can compile languages to a neutral binary format called WebAssembly and run it on all these different platforms. There's been kind of an explosion of interest in the different places where you could run that, ranging from embedded devices and IoT into like plugins and of course the browser. And then the one that we're most excited about is the cloud.
Serverless has long been the promise of cloud native, the ability to developers to build and run applications without having to manage servers, but it has had challenges in being widely adopted. What do you think what role will WebAssembly play in the next generation of serverless?
Yeah, and I think it probably helps to define just a little bit what we mean when we talk about serverless. To me, serverless is really a software development pattern. I mean, people will talk about whether the server we're referring to is a hardware server or a software server. I think of it as a software server. Essentially, we had been engaged in this practice all along in the cloud native ecosystem of building servers, building software servers that start up and they listen on a port for a long time, and they answer request after request. And that meant long running processes that, when you're paying per minute for compute, means expensive processes.
Right.
And what serverless came and kind of offered was two big value propositions. The first one is you're only running your software when you're handling requests. And the second one was really the developer story is much simpler. Instead of having to maintain this whole edifice of code that's basically running a server, managing TLS certificates, all of that kind of stuff, and then starting to build your core business logic, serverless really enabled you to dive right into the core business logic directly. You're immediately working on here's the request that I care about. I'm going to work on that request. I'm going to send back a response, and that's it. That's the end of my responsibility. And so it's no surprise that developers really sort of liked that method of engineering, of software engineering, that practice of software engineering, that particular design pattern. Mm-hmm. But the current implementation of serverless at that time, right, was built on kind of yesterday's technology. It was built on a virtual machine layer, or some of the newer ones are built on a container layer. But those were systems that were built and optimized for running long-running processes. A virtual machine may take several minutes to start up. A container takes a couple dozen seconds to start up. And if you're really trying to handle requests that are coming in and process the request and return a response as fast as possible, you're stuck with a kind of design catch-22, and that your core platform can't do it that fast. So you need to kind of work around that, which meant pre-warming instances and keeping queues of instances ready. And that meant driving the expense up. So so for a long time, this kind of serverless world was playing a kind of game between how much, how expensive is this going to be? How performant is this going to be? And then because really they're running on this kind of core technologies like virtual machines and containers that are not platform agnostic, the developers still actually had to know quite a bit about the server. So we were looking at this problem. Originally we were looking at this problem from behind the curtain. We were looking at it from Microsoft's perspective inside of Azure and going, it seems like we're wasting a lot of, well, if nothing else, power, right? Literally power, running these things in the background, waiting to queue up workloads. And developers were telling us, it needs to be faster, right? 200 to 500 milliseconds for a cold startup time is not fast enough. It's getting us dinged on our Google search results if, Google starts penalizing it around 100 milliseconds. And at 200 to 500 milliseconds of cold start time means you're not even running your code till then. So there were these problems and more, developer experience, things like that where developers were just sort of clamoring for having a better solution. And I kind of stumbled upon this when talking to developers about what they were excited about in the cloud native ecosystem. This really goes all the way back to 2018 when we started asking this question pretty routinely. And what I would hear and what other people on my team would hear was, well, this serverless thing is really cool. Really, really like the value prop of focusing right in on this kind of core piece of business logic. But all these other things are frustrating. And if I could just find a platform that didn't have the slow startup time and had a better developer experience, was cheaper to operate, was cross-platform and cross-architecture, that'd make me so happy. So it's kind of like having people define a product for you and say, here's my wish list of things. Can you build me one of these? And that's really, and that's why I think serverless is in this position right now where we're going to see a big resurgence of it. A recent book just came out called the Value Flywheel Effect. And the first part of this book is all about how serverless is sort of poised to make serious inroads in the way we write applications. And Adrian Cockcroft, who worked at, really defined the architecture at Netflix, wrote the foreword of it. And it's just a fascinating read to read this like seasoned architect who did so much good work saying, if I had just seen serverless coming, and once I saw serverless coming, and let me tell you how excited I am about the future of serverless, to me, that kind of optimism is well grounded because serverless really is poised to kind of make those kinds of inroads and replace some of these dominant patterns that existed in the previous 10 years or so.
What about how things fit into Kubernetes? Kubernetes has been very useful in orchestrating containers, but it's also pretty complicated and gets more so as it scales up. How can WebAssembly fit into this world of K8s and containers?
Yeah, I've worked on Kubernetes for a long time, deeply interested in it, both in past, present, and in the future. And the thing that it has, and you were right to point out that complexity is a big issue with the Kubernetes ecosystem. But it's one that many organizations have said, okay, well, we will buy into that. We will work with that. We still want to be able to run these serverless style workloads. And there are not terribly great solutions right now to run very high performance serverless workloads. But it's not at all difficult to run WebAssembly inside of Kubernetes. The Containerd project, which really, kind of a core chunk of the deep infrastructure of Kubernetes, they have, thanks to Microsoft and a number of other organizations that have contributed, they have a Wazi runtime. So essentially, you can define WebAssembly applications side by side with your containerized applications now. And as you deploy those, the ones that are containerized will get run in a container environment. Those that are WebAssembly will run in a WebAssembly environment. That really opens up this potential for us to just continue working with what we know, right? Keep on going with Kubernetes and keep on building the kinds of applications we're comfortable with building there, while also getting all the advantages of this serverless architecture for WebAssembly. So I think the future for Kubernetes plus WebAssembly is actually pretty bright. I know, and even I have to admit, I was kind of originally in this camp of saying, I think WebAssembly may be the Kubernetes killer, right? This might be the thing that, but as we've gotten going, we've realized that's sort of trying to compare apples and oranges in a way. Right. The WebAssembly is really, we're talking about a runtime. We're talking about virtual machines, containers, and WebAssembly now. And orchestrators sit at a level higher than this. And there is no reason why, any orchestrator from, Kubernetes to Nomad to, the kind of things that we write on weekends, all of these things should be able to orchestrate a wide variety of workloads if we're going to keep them flexible into the future. The fact that the Kubernetes ecosystem is so engaged in making sure that WebAssembly is supported alongside containers is a good indication that on the orchestrator layer, people are paying attention. We're making wise choices, and we're making sure that we're not orphaning an entire technology merely because something new and shiny came up.
You mentioned Wazi. That's WebAssembly System Interface, or Wazi to its friends. What is Wazi, and how does it help developers use WebAssembly outside the browser?
A system interface is really just a layer that glues together a runtime and the environment in which it's running, right? So WebAssembly originally being built for the browser, the runtime was living in an environment where it had to tie together with a JavaScript and a DOM and cascading style sheets and things like that. If we want to run it in other places, then we have to have a system interface to allow it to run in other places. A WebAssembly system interface, Wazi, is a system interface is designed to sort of represent an operating system-like environment. Now, there's a little bit of confusion about this sometimes. Some people look at Wazi and expect it to be a POSIX environment, right? Basically replicate circa 1979 Unix environment and kind of replicate the behavior of Linux and things like that. Well, Wazi is sort of intended to be a more generic layer than that. It's intended to sort of represent just a server-like environment or an operating system-like environment. And so originally, yes, it started implementing a number of the kind of features that we're used to from the past, like random number generators and system clocks and file systems, because those are really, really useful tools. But as the project's gotten going, the idea of a generic system interface has matured a little bit, and now what you see in Wazi is this effort to build a sort of pluggable architecture that would allow developers to specify these are the features that this particular system is going to provide. And the name of this whole engagement is called the component model. It's really like the most boring name for a very, very interesting project. And we can talk about that in a moment. But Wazi then itself is moving its way through a standards body. So it will be part of the W3 specification for WebAssembly, the Bytecode Alliance, which is a kind of loose consortium of a number of companies that are all working on building reference implementations and putting effort into building and maintaining and growing the standards. They've been working on the Wazi specification for quite a while, and it's just now, it's about to hit a new plateau of maturity with what they call Wazi Preview 2, which introduces networking and a variety of other sort of core system features into the definition of what an operating system looks like.
And what is Wazi Cloud? We've heard a bit about that.
And this is the perfect avenue to talk about what a system interface can provide for you, right? So here we're talking about, it's not necessarily POSIX, right? We're not just trying to replicate an old school Unix environment. We're trying to build sort of a pluggable layer that says, this is what my environment is. Wazi Cloud is a pluggable piece that you can plug into your WebAssembly runtime and say, yes, my WebAssembly runtime supports this system interface extension. And Wazi Cloud says, provides all the ones that you would assume are going to be inside of a cloud-like environment. So, for example, you would have networking, like HTTP, inbound and outbound. You would have key value storage, the kind of front-end definition of, hey, store and get these kinds of things that you might plug in a Redis database or MongoDB or something like that in the back end, and a variety of kind of other tools like that we, as contemporary cloud developers, just expect a cloud environment to have. So the name Wazi Cloud then is very specifically supposed to be, here's a system interface for WebAssembly that describes what a typical cloud environment looks like. So what can we do with something like Wazi Cloud? Well, Fermyon can implement this in Spin as a developer tool and say, hey, developers, you need these tools. Spin is a development environment that supports all of that Wazi Cloud specification. So in your development cycle, you can expect all these things to be here. Then say like Azure AKS can have a Kubernetes runtime that executes WebAssembly, and Fermyon can have Fermyon Cloud that also executes WebAssembly. And both of them can say, and when I say, I mean programmatically exposed to your program, yes, we both support the Wazi Cloud specification. Then I, as a developer, can write to a particular target and push it to either of these environments and know that my application is going to run and going to have all the services that it needs there. And so it's a really good way of sort of breaking down that idea of a system interface and saying, by system interface, we don't just mean Unixy, POSIXy thing. We mean, here's a core set of features, and then these extensions, the application can query and say, do you support these extensions? And if the answer is yes, the application can say, I can run in this environment.
So we talked a little bit about some of the advantages. What are some of the challenges thus far with Wazi Cloud?
I think the challenges really in all of the Wazi, and then definitely these trickle over into Wazi Cloud, there are two big ones. The first one is whenever there's a sense of urgency, as there is, we all want to be building as quickly as possible. But well-done standards are defined to progress on a fairly moderate cadence, right? That you don't want them to get too slow.
Right.
But you want to make sure that the right people with all the right background weigh in to say, yes, this looks good, or wait, on this one, we should probably tweak it a little bit. And when you're dealing with something like Wazi Cloud that's spanning networking and storage, and low-level programming, you want to make sure that you have people with networking specialty have a chance to come in and say, actually, if you do that, it's not going to scale up as effectively, while people in storage are saying, if you do that, you're not going to be able to handle, big data and things like that. And so the specifications tend to move on a sort of moderated pace. For a startup like Fermyon, that's like saying, so we're going to jog the first lap, and so it can be frustrating. And the easy way to deal with frustrations like that is to say, you know what, we're going to participate in the ecosystem. We're going to work on the reference implementations. We're going to work upstream. That's what made Kubernetes successful, right? Is all these companies from Google to Red Hat to, little tiny startups like Deis and to people like CoreOS, we were all kind of pooling resources in there to advance Kubernetes faster than it would go if we just said, all right, we'll let it plod along. And when it's mature, we'll jump in there. And I think Wazi and Wazi Cloud are really kind of in that same space where contributing actually helps advance things a little more quickly. The second challenge is really the challenge of much of computer science is figuring out what the right abstraction layer is. Things like key value storage are a good example because it's so simple, right? What's a key value storage do? Well, I supply a name and a value, and I store them in a database. And then when I want to get the value back out, I give it the name, and it gives me the value. And then hidden inside of that are all these kind of bugaboos, like how big can a name be? How big can a value be? Each and every a database may support something different. And so it becomes incumbent on the specification to say, we've defined at the right level of genericness that we can support a wide range of different backends while still giving the developer the kind of features that they need. And that one I think is going to continue to be a challenge for a long time as we all kind of learn what we need and how we need to define it. But initially, I think the developers so Wazi Cloud was introduced by Microsoft, and the developers who did the initial introduction had really thought through this. And they were developers who were very familiar with the Azure backend and with many of the open source tools. And so I feel like we got a really optimistic, really good head start on this simply because people with good exposure to a wide variety of technologies were the ones who initially proposed the specification. And
you mentioned Spin in that a couple of minutes ago. Do you want? That's a tool that Fermyon released last year. You want to just remind people what that is?
Yeah, so for us at Fermyon, in order to realize this kind of vision of a new wave of cloud computing, right, we've found we really need two things. The first one is we need an environment in which people could run these kinds of new wave of applications. And so we talk about Fermyon Cloud, or we talk about, the Containerd, WebAssembly shim. Those are all things where you can run this kind of next wave of cloud computing application, next wave of serverless application. But we also need a tool to be able to build them. And so we looked around and said, where did we see the most success in tools that got developers engaged? And Docker was the number one thing that came to mind. Docker did an extraordinary job in 2014, 2015 of building a set of command line toolings that really deeply resonated with the developer. And we said, we want to build one of those, that kind of thing, that will make it super easy for developers to take their idea about how to write a serverless app and have it built into WebAssembly and make it easy to deploy it into Fermyon Cloud or some other WebAssembly runtime. That's the vision behind Spin. So Spin, provides 4 or 5 top-level commands that make it easy to spin new, create a new project, spin build, compile it to WebAssembly, spin deploy, push it out somewhere and run it.
Okay. You've wrote an article for us for TNS in January for forecasting the year in Wasm, and you wrote, and I quote, 2023 will be the year that the component model begins redefining how we write software. What is the component model with regard to WebAssembly, and what impact will that have, or is it having on developers?
Yeah, we almost lost track of that component model thing. I mentioned it earlier, and I was afraid we wouldn't get to circle back. The component model, I think, is the really big deal. The one feature that's going to make WebAssembly stand out among, sort of a landscape of existing technologies, because it's enabling something that we simply have never been able to do before. So now I made a really big grandiose claim, and I think I have to back it up by explaining what exactly that thing is, right? And so again, we can go back just a moment and say, okay, well, we're talking about system interfaces, and Wazi is a way to build system interfaces, and being able to extend and say, okay, now we've got Wazi Cloud, and that supports these system interfaces. The component model it takes this even one step further and says, what we should be able to do is provide sort of a common way for WebAssembly libraries to say, these are the things I need, these are my imports, and these are the things that I provide, these are my exports. And then we can compile that WebAssembly module, and it can express its needs, and we can take another WebAssembly module and we can start joining them up. This thing needs key value storage. This thing provides key value storage. Look, they work together. This thing needs a YAML parser. This thing provides a YAML parser. Look, they work together. And so that's sort of like at the core, what the component model is just a way to describe each of these libraries as what the specification calls a component, and then defines a component interface language where they can express their needs and what they provide. Now, this all sounds a little bit jargony and technical until you look at what this should enable. If you can really compile languages, all these different languages, including Python and Ruby, Java, .NET stuff, Rust, C, if you can compile all these to a common format, and then each binary can express its capabilities and what it needs to import and what it needs to export, or what it can export, suddenly one of the biggest barriers in computer science has been broken down. And that is that we no longer have to pick one language and stick completely inside of that language ecosystem. Suddenly, without even knowing what the source language was, I can write a Python program that imports a JavaScript library, a Rust library, a Zig library, a C library, and uses all of those in conjunction without any of them knowing the source environment that any of them are. And so when you think about the way that programming languages have evolved over time, and every 5 to 7 years we see a new superstar programming language, and we watch this pattern repeat. The language drops, and then it takes a couple of years as everybody has to build up the same set of libraries. It needs an HTTP library, it needs a YAML parser, it needs a threading library, and so on. And then we have every language with its own libraries, and there are incompatibilities between, say, the YAML parser in one language, the YAML parser in another language. And we end up as engineers just duplicating on a massive scale the same kind of work in a whole bunch of different programming languages. And now it looks like for the first time, we have this opportunity to say, actually, we just can reuse the ones written in different languages. When a new language shows up, if it can compile to WebAssembly and use the component model, it can pull in libraries from other things. It reduces the barriers there. It means that the maintenance of existing libraries begins to shrink. And ultimately, it means the developer has this phenomenal experience of being able to say, hey, I can pick from any of this. If I want to use, NumPy from Python in a Rust program, I can do it with no extra work on my part. And that really is a big game changer. That's what's really exciting about the component model.
Yeah, it seems like it delivers on that. What I've always heard about WebAssembly, it basically means, build once, run anywhere. And that seems like it's literally delivering on that promise.
Absolutely. Yeah.
In addition to the component model, what's emerging on the Wasm landscape that you're most excited about?
I think that, kind of throughout the WebAssembly landscape, we're seeing you're always going to see first, right, the rise of a couple novel tools to show off what's valuable about this technology. And then you're going to start to see the leading production applications. And I think Fermyon really is in that category of saying, here are things that we've got a problem. This whole serverless thing we talked about at the beginning, we've got a solution. And you see those kinds of things coming second, right? So what tends to happen in kind of that third generation, that third progression as development happens, that's tooling, right? And by that, I mean, how do I debug more efficiently? Containers were very difficult to debug because essentially the thing inside the container is sort of opaque to the user. I can't see inside the container and see what all is running and instrument it and debug it from outside. WebAssembly is not that way, right? I can instrument WebAssembly real time. So that means tracing and debugging and logging and gathering metrics and all of the kinds of tasks that make an operational environment much more robust and much better for the operational team. Those are just now starting to come along. So I think we'll see a lot of those coming in the next year or two. That'll bolster the security story because we'll be able to have these very sophisticated security tools that can warn us about things well in advance of what today's infrastructure can. It'll be better logging, it'll be better debugging, and ultimately it'll be better optimization as we can kind of inspect how things run. So to me, the most exciting tools that are coming out right now are the ones that are essentially attempting to squeeze a little more information and a little more utility out of the existing WebAssembly binary format and the existing WebAssembly landscape.
One last question. You mentioned you used to be someone who thought that WebAssembly would be a Kubernetes killer, and don't think that anymore. Do you think WebAssembly could potentially be a containers killer?
I think the main distinction between WebAssembly's strong points and containers' strong points is, again, that short-lived versus long-lived process thing. WebAssembly, the virtues of it are its fast startup time, its portability, its tiny little binary sizes. All of those things are really important when you're building serverless workloads. Not as important when you're running something that's a long-running process. The big virtue of containers, it's really got two. The number one is you can run just about any existing application inside of a container with no work, right? You don't have to think about the component model. You don't have to think about recompiling it to WebAssembly or anything like that. It just works. And the second one is really that it's optimized for long-running processes. So to me, I see these as being two really complementary ways to build more sophisticated applications where one of them will be the long-running database or long-running storage system, and the other one will be the kind of serverless, boom, handle over request, boom, handle over request, kind of ultra fast kind of one. And so that's why I don't necessarily think WebAssembly and containers will end up competing. That said, there's always, the Venn diagram's always going to overlap a little bit, right? And we're always going to see people saying, well, maybe this one thing that was done in containers, maybe it could be done a little bit better in WebAssembly. And that I think is fine. So you'll see some anecdotal evidence that WebAssembly is eating into the container ecosystem, but really it's only because you got a little bit of overlap on that Venn diagram. I think long-term, each one is going to occupy its niche.
Okay. And I guess that's a wrap. It's always a pleasure to talk to you, Matt. We've been talking to Matt Butcher of Fermyon Technologies, and thank you for joining us today.
Yeah, thanks again for having me. This has been a great time.
And for me as well. And we'd like to thank Fermyon Technologies for sponsoring today's conversation. And we'd like to thank all of you for joining us. And this has been Heather Joslin for the New Stack Makers. We'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.